Okay, so we're going to talk about customer loyalty and how we can use AI to actually gain a better understanding of how our customers see us and then what we can do about it. Okay, this is a typical disclaimer. Basically, I do not represent any government or any individual or any company at this presentation. These are purely my own thoughts based on about 30 years of professional experience. Now, we're going to talk about basically how loyalty links to profitability, what loyalty is composed of, and how we can measure it using machine learning, and what we can do to actually increase the way our customers see us, something known as the loyalty gauge. First of all, everyone knows that business continuity has to do with customer loyalty. This is not rocket science. It's hindsight, it's common sense. The problem is that when something is common sense, it can actually be doubted. Today, we have data that proves this. In other words, in Sweden, in the banking center, as well as in some other countries, studies have been done with data which shows that we can actually measure customer loyalty and then build a model to predict profitability a year after. So we actually have linked customer loyalty to profitability. And a small increase in loyalty can actually lead to a substantial increase in profitability. Now, before we get into the actual models, one thing we have to understand, and this is based on Danny Kahneman's Nobel winning work, which has to do with the way we model the human brain, that we are basically composed of two systems. First is system one, which is the initial, if you want, dinosaur type brain that we had before we evolved into something that we call human, okay, which allows rational thought. And system two, which of course is rational thought. System two takes up a lot of energy. That's why system one is usually used more. So when you're driving, you don't really think that much. And if something comes out of the ordinary, you instinctively do whatever you do, an evasive maneuver to avoid crashing or whatever. This is system one. It has allowed us to survive. System two allows for philosophical thought, of course, for advanced thought. It makes us human. Now, there's one issue with all this. First of all, those two systems are connected by an organ known as the amygdala. The amygdala is a switch. System one has a high bandwidth access to system two, the higher cortex, but the higher cortex has a limited access to system one. Why is that? Well, basically, the way we have evolved, we allow emotions to quickly take over rational thought, so that, for example, if we're contemplating the universe and a lion shows up in front of us, we immediately start running without thinking. Okay, that's called hijacking the higher cortex. The other way around is more difficult. In other words, controlling your emotions, and that can be accomplished, of course, with meditation, with a lot of training, and with Socratic thought, questioning your own thoughts and emotions. Okay, now why is that important? It's important because every piece of rational thought is influenced by emotions, and thus the weakness in game theory. Humans are not rational. They try to be, but they cannot be because they have inherent emotions that affect the way we think. And loyalty is one of those behaviors that is affected by emotions. And we have models for this. Okay, so loyalty is affected by emotions. Here are some of the emotional drivers. Okay, this is based on one emotional model known as Planchek's model. This is the model that is used by experienced designers when they make user interfaces. And you can see that the loyalty vector is composed of a number of eigenvalues. That is honesty, trust, integrity, and so forth. In other words, if we can measure honesty, trust, integrity, belonging in a particular communication, and I'll get more into that, then we can use a gauge to see the amount of loyalty that we have out of these, that is the result of these emotions, and take further steps to actually adjust our attitude towards our customer by enhancing the emotions that basically encourage loyalty and have a change in behavior. This is done not through surveys. It's not done through any kind of, let's say, numbering system. This is done typically through what is known as unstructured data, which is 80% of the data that we basically have in any company. It's text, it's voice, it's any kind of interaction that has to do with language, okay? And the way we measure this is through something known as natural language processing, machine learning, where we take this data and we incorporate it into a model that's trained. Okay, for those that basically know something about this, this is called supervised learning. And after that, we can actually predict the emotions that come out of all this data. Just to give you an example, if you have, let's say, about 30 gigabytes of data, for those that are into machine learning, and you use a model known as, what you might call it, random forest, doing a 10-fold cross-validation in 3 iterations, it gives you in a 10-core processor, okay, in about 28 minutes, you get an answer that's 96% accurate. That's fantastic, by the way. 96% accuracy means that your machine learning algorithm can accurately predict the emotions of your customer based on your communication with this customer. This is Planchik's model. I'm showing you exactly the emotional loyalty vector with the eigenvalues that we're talking about. Here's an example, by the way, okay? Say that I get this message through an email. My machine learning algorithm will basically analyze it and tell me that, look, your customer is feeling joy and is feeling anticipation. This means that if your customer is feeling joy and anticipation, these are the eigenvalues of the loyalty vector. And what I can do is I can gauge the amount of loyalty I have. And this is how much loyalty my customer has. My customer is, okay, is getting there. He's pretty loyal. Okay? He's not exactly where I want him to be, but I know what to influence to get him to be more loyally. What do I influence? I'll influence these two emotions. This is one particular emotional model. There are other more advanced ones that we can translate into predictive models, into machine language, right? Another example, this is a negative statement, okay? These are actual statements that have come in different companies. I've scraped them off the internet. Look at this. The algorithm that I use has given me that the customer is not happy. He's quite sad, actually. He's angry, and he's quite disgusted at the way we're behaving. And translating that into the loyalty gauge, you can see that, well, no, it's not there. The blue is in the red. That means we're in trouble, especially if this is a strategic customer. Then we're really in trouble. Now, this is actually from a rock band. This is after 40 years. Look at this, for those of you that are in business. Look at these values. Look at the trust. Look at the joy, and look at the anticipation. After 40 years, this rock band is still strong. Okay? I'm not going to tell you which rock band it is. You can guess. Look at the loyalty gauge. We wish in the corporate world that we get there. We have a lot to learn from the entertainment business, especially from the strong players in the entertainment business, the ones that basically have gone through time without any effect. So to wrap it all up, yes, through communication, speech, whatever, we call that unstructured data, we can measure loyalty. We can see what emotional components comprise this loyalty behavior, and we can work ourselves to change the way we address our customers in order to influence the way they look at us. Because like we all know, before you change someone else's behavior, it's good that you look at your own behavior, because the way you behave influences how they behave. It's very difficult to do, but that's where we should start. And this has to do also with corporate culture and with everything else that has to do with human interaction. And of course, like I said before, anything we do has to respect privacy, and it has to be ethically correct. Okay? Thank you very much.